protecting edge devices and data. With the increased adoption of edge computing, protecting edge devices and data has become crucial. Security considerations for microservices deployed at the edge are essential in safeguarding the integrity, confidentiality, and availability of the systems. In this part of the course, we explore various measures to protect edge devices and data. Device authentication is crucial for ensuring that only trusted devices can access the edge environment. It involves verifying the identity of each device before granting access. This can be achieved by implementing secure protocols such as mutual authentication, where both the device and the edge node authenticate each other using certificates. Additionally, robust access control mechanisms should be in place to enforce device authentication. Implementing data encryption. Data encryption is essential for protecting sensitive information from unauthorized access. Encrypting data at rest and in transit ensures that even if it is intercepted, it remains unintelligible to unauthorized individuals. Utilize industry-standard encryption algorithms and protocols such as AES, Advanced Encryption Standard, and CSL/TLLs, Secure Sockets Layer, Transport Layer Security, to encrypt data both at the device and during transmission. Implementing Secure Boot. Secure Boot ensures that only trusted firmware or software is executed on the device, preventing the execution of malicious code. It involves validating the integrity and authenticity of the firmware or software during the boot process. Implement mechanisms like cryptographic signature verification to ensure that only authorized and unmodified firmware or software is loaded onto the device. Performing regular software updates. Regular software updates are critical for keeping edge devices secure. Software vendors frequently release patches and updates to address vulnerabilities or bugs. Device manufacturers should establish a process for securely updating edge devices with the latest firmware and software updates. This process should include cryptographic checks to ensure the integrity of the updates and utilize secure communication channels for the update process. Implementing intrusion detection and prevention systems. Deploying intrusion detection and prevention systems, IDPS, helps in detecting and mitigating potential security threats. IDPS continuously monitor network traffic and device behavior to identify any suspicious activities. When an anomaly is detected, the IDPS can take preventive actions to mitigate the potential damage, such as blocking traffic from the source of the attack or alerting the system administrators. Implementing secure network segmentation. Network segmentation divides a network into smaller, isolated segments, limiting the impact of a security breach. By segregating edge devices into separate networks with defined access controls, potential attackers are contained within a single network segment, minimizing their ability to move laterally and access critical resources. Implement robust network firewalls and virtual private networks, VPNs, to enforce network segmentation. Conducting regular security audits and vulnerability assessments. Regular security audits and vulnerability assessments are essential for identifying potential security weaknesses in the edge environment. Conduct comprehensive assessments to identify vulnerabilities, potential attack vectors, and misconfigurations. Address any identified issues promptly to maintain the integrity of the system. Applying principle of least privilege. The principle of least privilege ensures that each user or device only has access to the resources required to perform their tasks. Implement effective access control mechanisms and restrict privileges based on job roles or device capabilities. This minimizes the potential damage that can be caused if a user or device is compromised. Protecting edge devices and data is a critical aspect of ensuring the security and reliability of microservices deployed at the edge. Based on device authentication, data encryption, secure boot, regular software updates, intrusion detection, and prevention systems. Secure network segmentation. and conducting regular security audits, organizations can proactively safeguard their edge infrastructure and mitigate potential security risks.